In this lecture, we are going to see some more numerical methods to solve ordinary differential equation. Already in the previous lecture, we saw the first method to solve ordinary differential equation of first order, first degree, that is Euler's method. In this lecture, we are going to see some more methods by which we can easily solve differential equation of first order, first degree. Okay, so we'll begin with lecture 5, numerical solution of ordinary differential equation. I just recall what we had done in last lecture. We have taken the Euler's method. In that, we are given a differential equation of first degree, first order, that is dy by dx. We consider that as f of xy. We have also given the initial condition, value of y at some point x0 is given. We denote it by y0. And it is asked to find the value of y at some point x. At which point we want to find a value of y, that point x, we denote it by xn. And then from x0 to xn, okay, divide these interval into n subintervals of width h. Generally, this n and h, n or h is given in the problem, or otherwise you can take it off your choice. And then by using that n and h, we have to take the next term x1. x1 will be x0 plus h, x2 will be x0 plus 2h. Like that, we have to go up to xn, and we can find the value of y at that xn. Okay, and that will be the solution of this equation. Now, what happened? Here we are finding the value of these terms. This value of y at x1, value of y at x2, or value of y at xn. We get a single value. Okay, and many times we are having this is not so much accurate value. But if you want to get more accurate value, we try to modify this value. We try to get some accurate value by doing some modification with these formulas, and that modification to get more accuracy is obtained by using the next method, and that is called as a modified Euler's method. Now, what is this modified Euler's method? We use the Euler's formula only for finding the first terms, and for finding the rest of the terms, we use some more formulas. So we'll see what is that method. First part is same. We have to find the value of y1 by using the Euler's formula, that is y0 plus h f of x0 y0. This was the formula which we saw in Euler's method. y1 equal to y0 plus h f of x0 y0. We consider that y1 as zeroth term. Okay, this we call as a zeroth iteration. And then after getting this, we find the next term. We try to modify this y1 by using this formula. Okay, this we call the nth iteration of y1, and that is given by y0 plus h by 2 f of x0 y0 plus f of x1 y1 n minus 1 iteration of y1. Okay, so if you want to find y1 first iteration, then here we take zeroth iteration, that is the value we get from this, and sum of that divide by 2, that is the mean of these two values into h plus y0 will be the next iteration. So what to do? Firstly, get the zeroth iteration by using Euler's formula. Then for finding the next iteration, find the mean of f of x0 y0 and f of x1 and y1, which we got from this Euler's formula, and take mean of that, multiply by h, and take addition with y0. That gives us the next iteration, and continue like this until the two successive values of y1, until two successive values of y1 are approximately equal. Okay, and whichever values are equal, we take that as a y1. What happened in Euler's method? We directly take this as a y1. But what happened many times there may be some error. So how to overcome that error? That can be overcome by using this modified iteration formula. Okay, we try to get more accurate value by using this iteration formula. Okay, find the first iteration, second iteration, continue until that two iterations get match up to desired accuracy. If it is asked up to 2 decimal places or 3 decimal places, accordingly we have to continue, and whenever they match, take that as a y1. Then uh, if you want to find the next term y2, then first find y2 by using Euler's formula, y1 plus h f of x1 y1, and consider that as a zeroth iteration. Okay, so for finding the first iteration, we use Euler's formula only. We called that as a zeroth iteration, and the nth iteration is nothing but f of x1 y1 plus f of x2 y2, n minus 1th iteration of y2, whole the term divided by 2 into h plus y1. Okay, so we take the mean of these two terms into h plus y1. That gives us the nth iteration for y2, and continue like this until the two values of y2 get match. And when the two values of y2 get match, we take that value as a y2, and then we continue, and we have to continue until we get yn term. Okay, because generally we have to find we are given x naught y naught, and it is asked to find what is the value of y at xn. So we have to continue until we reach up to yn. Okay, so only one separate formula we have to remember. This formula, this first formula already we use in Euler's method. Only some modifications we are doing. We are modifying our answer. Okay, in Euler's method we got this answer, but this is not so much accurate value. So to get more accurate value, we are doing this modifications. Okay, and that modification is an iterative process. What we do, we use this formula repeatedly to get the next iteration until two terms get match. Then find a new value, use iteration method, modify new value, then find y3, use iteration method, modify that, get y3, modified value of y3, then calculate y4. Like that we have to calculate up to yn term. Okay, so this is also very easy. Two formulas we have to remember. First formula already used for Euler's method, and this is the second formula, modified iteration formula. Okay, now we'll take a problem and we'll see how to make use of these two formulas to get the more accurate value for ordinary differential equation. Find y at point 1 by using modified Euler's method if y dash is equal to 3e raised to x plus 2y, given y of 0 equal to 1, and take h is equal to 0.1. Okay, so firstly write down what are the given things. We are given y dash, means dy by dx is given to us. So dy by dx, that is y dash, is 3e raised to x plus 2y. That we take it as f of xy. Then y at 0 is given, means the 0 is nothing but x naught, and the value of y at x naught is nothing but y naught. So we are given x naught and y naught. Y at 0 is 1, so this is the inside value is x naught, that is 0, and y naught is 1. H is 0.1. So first find what is x1, then find the value of y at x1, and then simplify it. So what will be x1? X1 will be x naught plus h, that is 0 plus 0.1, so that is 0.1. And now by Euler's formula, y1, that is y at x1, will be y naught plus h into f of x naught y naught. But as we are using modified formula, a modified method, we take this as a zeroth iteration. If it is only Euler's method, then this gives us the answer. Only this formula we use. But if it is modified, then we take this term as a zeroth iteration. Now put what is x naught, y naught into this function, take h, okay, and do the simplification. So y1, zeroth iteration of y1 will be y at x1, that is 0.1, equal to 1 plus 0.1 into 3 into e raised to x0. x0 is 0 plus 2 into y. y is y0. So that is 1. So simplify it, get the answer. So zeroth iteration is 1.5. Zeroth iteration of y1 is 1.5. Now, take note of the modified Euler form. First iteration of y1 is y naught plus h by 2 into f of x naught y naught plus f of x1 y1. Zeroth iteration of y1. F of x naught y naught plus f of x1, zeroth iteration of y1. If it is 1 here, then we get 0 here. If we are having second iteration, then we took the first iteration of y1 here. We just have to take the previous iteration. Okay. So we know what is f of xy. Put x naught y naught into it. We know what are x naught y naught. Put it into this function. Plus we know what is x1 and zeroth iteration of y1. Zeroth iteration of y1 is 1.5. So put x1 as 0.1 and y1, zeroth iteration of y1 as 1.5 into this given function. So the first iteration of y1 will be 1 plus 0.1 by 2 into 3 raised to 0 plus 2 into 1, same function which we have got here. We take that one here plus 3 into e raised to x1. x1 is 0.1 plus 2 into y1, that is 2 into 1.5. Simplify it. So first iteration comes out to be 1.5658. Now check whether these two values of y1 are same or not. Zeroth iteration and first iteration. They are matching only up to one digit. Okay, so we will do further calculation. Okay, only first digit 5 is matching. Here rest of the terms are 0, 0, 0, but they are not matching with these terms. So we are finding some further iteration. So take this as first iteration and find the second iteration of y1 and then do the simplification. While finding the second iteration, we use this first iteration of y1 for doing the calculation. Okay, so the second iteration of y1 will be y naught plus h by 2 f of x naught y naught plus f of x1 y1 first iteration. Substitute that values into the function and then do the calculation. Simple calculations are there. That gives us y2 y1. Second iteration is 1.5724. Now we check whether these two are matching or not. First iteration and second iteration. Again, they are matching up to one digit only. The second digit is 6, here it is 7. So they are not matching further. So we are doing some further iteration. So use the formula, get the third iteration. For calculating third iteration, we use this second iteration for f of x1, second iteration of y1. First term as it is. So keep rest of the terms as it is. Just change y1 by this iteration and again do the calculation, just replacing this last term by 1.5724 doing the calculation. So third iteration of y1 is 1.5730. These two are matching up to 2 digits. So if it is asked in exam that check get the answer match up to 2 digit, then this is the answer. If you want some more uh, terms to match, you can do further iteration. Suppose we want up to 3 digits, so we'll do some further iterations. Say fourth iteration, replace this y1 at second iteration by y1 at third iteration. So do the simplification with these terms. So fourth iteration will be 1.5731. And you can see that these two are matching up to 3 decimal places. So we can now take this value. If you want up to 4 decimal, you can take one more iteration. Okay, here we are considering up to say 3 digits, 3 decimal places. So value of y at 0.1 is 1.5731. Okay, so what we do in modified Euler method, firstly we find the value of y by using Euler's method, and we try to modify that by using this iterative formula. Okay, so carefully remember that basic formula. Depending on this function, we get the corresponding terms over here. Okay, find y of 0.2, correct up to 2 decimal places by using modified Euler's method. If y dash is equal to xy plus y square, given y of 0 equal to 1, and take h is equal to 0.1. So again, take that y dash as dy by dx and take all that function as f of xy. Then we are given y of 0 equal to 1. So we are given the values of x naught and y naught. H is also given in the problem, so we can make use of that. So f of xy will be xy plus y square. Y0 will be 1, so x naught is 0 and y naught is 1. H is 0.1. So first find the value of y at x1. H is given 0.1, so it will be x naught plus h. 0 plus 0.1. So x1 will be 0.1. So firstly we'll get the value of y at 0.1, but we want to find at 0.2. So firstly we find y1 by using approximate formula. Then we find y2 because we want to go up to y at 0.2. By using first formula, we get y at 0.1. But in this problem, it is asked y at 0.2. So we have to find the value of y2 also. Okay? If it is given 0.3, then we have to find y3. Okay? Depending on this term, from starting point 0, we have to reach up to 0.2 by using h. So depending on that, we have to simplify. So firstly use Euler's formula, get y1. So y1 0th iteration will be y at x1, that is y naught plus h into f of x naught y naught. Substitute the values, x1 is 0.1, y naught is 1, h is 0.1, function is xy plus y square. Replace x by x naught, replace y by y naught. X naught is 0 and y naught is 1. So it is 0 into 1 plus 1 square. Simplify it. So the 0th iteration is 1.1. Now, for finding the first iteration, use modified iteration formula. So iteration formula is, first iteration will be y naught plus average of f of x naught plus f of x1, 0th iteration of y1 into h by 2 plus y naught. Okay, so replace this f by this function, put x naught y naught into that function, and put x1 and 0th iteration of y1 into that function and simplify it, and continue until two values of y1 get matched. So doing the substitution, simple calculation is there. So we get the first iteration of y1 1.116. Up to 1 digit they are matching, but here it is asked up to 2 decimal places. So we have to do further calculation. So take this as first iteration of y1 and then find the second iteration of y1 again by using iterative formula. So second iteration of y1 will be y naught plus h by 2 into f of x naught y naught plus f of x1 y1 first iteration. Now you use this value while doing the calculation 1.116. Same function, rest of the terms are also same, only replace y1 by this new value. Okay, simple calculation, we get y1 second iteration as 1.1179. Whether these two are matching? Yes, these two are matching up to 2 decimal places, so we can take this as y1. If it is asked up to 3 decimal, we'll have to do some more iterations. But in this problem, it is asked up to 2 decimals, so these two are matching. So we can take this next iteration as the value of y1. Okay, therefore y1 will be y at 0.1, that will be 1.1179. Now we want to find the value of y at 0.2. This we got y at 0.1. So we have to use the formula for y2 also. Now to get y2, firstly use Euler's formula. For getting y2, we need x2. And what is x2? x0 plus 2h or x1 plus h. You can use any of the formula. Okay, add h to previous term or x0 plus 2 times h. That will be 0.1 plus 0.1, that is 0.2. So by Euler's formula, y2 will be y1 plus h into x1 y f of x1 y1. Now take this term as y1, which we got by using these modified terms, and do the simplification. So zeroth iteration will be 1 plus h is 0.1 into 0.1 into 1.1179 plus 1.1179 square. Okay, and simplify it. Okay, this by mistake I have taken 1, it is 1.1179. Okay, we are using the modified value of y1. This is 1.1179. Now do the simplification. It comes out to be 1.1. Now again, we have to use the modified formula to get the iteration. So using the modified formula, the first iteration of y2 will be y1 plus all this term. Okay, so use that modified formula for first iteration of y2. For that, use the zeroth iteration of y2 and then simplify it. So use the standard formula, do the substitution, and simple calculation gives us the next iteration. Okay, so y2 will be, first iteration will be y1, that is 1 point all that term. By mistake I have taken 1, it is 1.1179. Put it into this inside terms and then simplify. Okay, we get second iteration. Sorry, first iteration. Now these two are not matching up to 2 decimal places, so we have to do further calculation. Get the second iteration. In second iteration, take this new value of y1 for finding the second function and then simplify. Okay, so the second iteration is 1.1444. Again, these two are not matching up to 2 decimals, so take further iteration. And in the third iteration, you can see that this is 1.1444 and this is 1.1450. So up to 2 decimal places, these two values are matching. So we take the value of y2 as 1.1450. So value of y at 0.2 is 1.1450. Okay, so repeatedly using this iterative formula, we modify the answer which we get by using Euler's formula. So because of that, it is called as a modified Euler's method. Okay, this gives us the more accurate value than the Euler's method. Okay, now there are some more methods by which we can get the solution for ordinary differential equation. The next method is Runge-Kutta method of fourth order. Okay, there are Runge-Kutta method of different order. The most commonly and very important is fourth order method. Now what is this method? We are given a differential equation of first order dy by dx equal to some function, say f of xy. We are given the initial point f of x naught equal to y naught. Then at which point we want to find uh, y, take that as x, and it is generally denoted by x naught plus h. And then by using this Runge-Kutta method, the value of y at x naught plus that h will be y naught plus k. And finding the formula for k is, the method for k is 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. And for each, we have the formulas. K1 is given by h into f of x naught y naught. K2 is given by h into f of x naught plus h by 2, y naught plus k1 by 2. K3 is h into f of x naught plus h by 2, y naught plus k2 by 2. And K4 is h into f of x naught plus h, y naught plus k3. Okay, so this is not an iterative method, fixed formula. Just by using these formulas once only, we can get the answer. It is not like modified Euler method. We have to do the calculation only once. So what are the calculations we have to do? We have to calculate k. Y naught is given in the problem. We just have to calculate k. And for finding k, these four values are used. K1 is what? H into f of x naught y naught. K2 is h into f of x naught plus h by 2, y naught plus this k1 by 2. K3 is h into f of x naught plus h by 2, y naught plus previous value, that is k2 by 2, and k4 is given by h into f of x naught plus h, y naught plus k3. Okay, so making use of these four k's, we get this k, and addition with y naught gives us the answer. Okay, it is not an iterative method. It is a just substitution and calculation part. Okay, and carefully remember all these formulas, because these formulas, any formula can be asked for multiple choice question. Okay, what is the value of k, or what is k2, or what is k4? Okay, so these formulas are very important in this. Rest of the part is just simple calculation. Okay, just putting the values into this formula, getting these values and putting it into this to get y naught plus k, that is the required value for y. Okay, so it is also very easy. Important is remembering these formulas. That is very important. Okay, now I'll take a problem based on this Runge-Kutta method. Find y at 1.1 by using Runge-Kutta method of fourth order if y dash is equal to 1 minus xy divided by x square, y at 1 is equal to 1, and h is equal to 0.1. So whatever given function is, whatever given differential equation is there, take it as dy by dx and equate all that term to f of xy. So this is our function f of xy. X naught is 1, y naught is 1. Okay, y at 1 is 1 means x naught is 1, y naught is 1, and h is given as 0.1. And what we want to calculate value of y at 1.1, that is x naught plus h. At that point we want to find y. So y at 1.1 will be y at x, that is x naught plus h, and by Runge-Kutta method it is y naught plus k. Okay, So we have to calculate this k. And formula for k is 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. And formula for k1 is h into f of x naught y naught. We know what is h, we know what is x naught, we know what is y naught, we know what is the function. So put x naught y naught into this function. Put x naught as 1, y naught as 1 into this function and do the simple calculation. So it will be 0.1 into 1 minus 1 into 1 divided by 1 square, because both x naught and y naught are 1. 1 minus 1, 0. So k1 comes out to be 0. Now find out k2. K2 will be h into f of x naught plus h by 2. X naught is 1, h is 0.1. 0.1 by 2 is 0.05. 05. So 1 plus 0.05, that becomes 1.05. Y naught is 1. K1 is 0. 0 by 2 is 0. 0 plus 1 is 1. So replace x by 1.05 and replace y by 1. So k2 will be 0.1 into 1 minus 1.05 into 1 divided by x square, that is 1.05 square. Okay, we are using these new terms. Okay, we know what is h, we know what is x naught, we know what is k1. So using that terms to do the further calculation. So k2 comes out to be minus 0.0045. Okay, now use next formula k3. We know what is h, we know what is k2. Substitute that k2 here, substitute x naught, y naught, and put all these values into the given function and do the calculation. Simple calculations, just substitution and calculation gives us the value for k3. Okay, x naught plus h by 2 already we saw it is 1.05, y naught that is 1 plus k2 that is negative of minus 0.00 whatever point which we got divided by 2, that comes out to be 0.9977. Doing this calculation we got k3. Now put this k3 into k4, h into f of x naught plus h, y naught plus k3. X naught is 1, h is 0.1, so x naught plus h, y naught is 1, and k3 is this term. So 1 minus this, whatever term we get, put both these values into the given function and do the calculation. So putting that values and doing calculation, it comes out to be minus 0.0079. And now put all this k1, k2, k3, k4 in the formula of k. So k will be 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. And then putting all these 4 values in this, we get a k. So k will be minus 0.0043. And therefore y will be y naught plus k. Y naught is 1, k is minus 0.0043. So we got value of y at 1.1 as 0.9957. Okay, so it is also very easy. It is similar to Euler's method, but it doesn't have to do iterations over here. We just have to find the values of k1, k2, k3, k4 once, and then using the formula of k, adding it to y naught, we can get the solution. Okay, so properly remembering the formulas and rest of the simple calculation, we can get the answer. Consider the next problem. Find y at point 2 by using Runge-Kutta method of fourth order if y dash is equal to square root of x plus y at 0 is equal to 1, and h is equal to 0.2. So again, given function, we take it as f of xy, square root of xy. 0 is x naught, and y at 0 is 1, means y naught is 1. H is 0.2. Okay, and what we want? we want to find a value of y at 0.2, and x naught plus h is nothing but 0.2. So we want to find a y at x naught plus h, that is by by Runge-Kutta method, it is y naught plus k. So firstly find k. For finding k we need these four terms: k1, k2, k3 and k4. So first find all that k terms. K1 will be h into f of x naught y naught. X naught is 0, y naught is 1. Square root of 0 plus 1 is 1. 1 into 0.2 is 0.2. K2 will be h into f of x naught plus h by 2, y naught plus k1 by 2. X naught is 0 plus 0.2 by 2 will be 0.1. Y naught is 1 plus k1. K1 is 0.2 divided by 2. So simplify it, put that values into this function and multiply it by h and simplify the terms. So that gives us k2 as 0.2191. Then find out k3 by using this formula: h into f of x naught plus h by 2, y naught plus k2 by 2. We know what are h, what is k2, x naught, y naught and h. Put that values to get k3. And then after getting k3, find out k4, and using all that values of k1, k2, k3 and k4, we can get k. After calculation, k3 comes out to be 0.2120. K4 will be h into f of x naught plus h, y naught plus k3. Do the calculation, x naught plus h will be 0.2, y naught plus k3 will be 1.2120. Square root of that into 0.2 gives us k4, 0.2377. And so k will be 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. And so k will be 1 by 6 into, doing the substitution of all k terms into this formula. So k comes out to be 0.2167. And add y naught to it, gives us the answer. So y at 0.2 is y naught plus k, that is 1 plus 0.2167. So the answer is 1.2167. Okay, so we have to use these formulas properly to get the value of y at the required point. If it is asked to find the value of y at 0.4, then what to do? Firstly, we have to find y at this point. Then take this as x naught and take this as y naught, and again do the same calculations. Okay, this is now because of h, we can reach up to 0.2, means up to this point. So we got the answer. But if it is h is given 0.2, but if it is asked to find what is y at 0.4, then after getting y at 0.2 by using this method, we take this 0.2 as x naught and we take this value as y naught, and then again do the same calculation to get the value of y at 0.4. Okay, but in this problem it is asked up to 0.2 only, so this is the answer. If it is asked up to 0.6, then again do the same thing. Firstly find y at 0.4, whatever value you get, take 0.4 as x naught, new value as y naught, and do the same calculation. So depending on h, this Runge-Kutta method we have to simplify. That many times we have to use that formula. In how many steps we reach up to this x, that many times we have to use this formula. In both this problem, we reach up to this point by one step. So only using this formulas once we get the answer. Okay, so this was the one more method by which we got the solution for ordinary differential equation. Now there is one more method, last method to solve the ordinary differential equation, that is predictor-corrector method. Now what we do in this method, Actually, we by using one formula, we predict the value of y at a given point, and another formula. There is one more formula by which we can correct that value. Now, what are that points? Okay, suppose we are given the function, we are given a differential equation, say dy by dx equal to f of xy, y of x naught equal to y naught. Okay, then the predictor Milne's predictor formula is predicted value of y4 is y naught plus 4h by 3 into 2f1 minus f2 plus 2f3, and the corrected formula is y4c is equal to y2 plus h by 3 into f2 plus 4f3 plus f4. Now what are these f1, f2, f3 and f4? The f1 is nothing but f of x1, y1, f2 is nothing but f of x2, y2, f3 will be f of x3, y3, like that. Okay. So for using this method, what we need? We need 3 points. These 4 points: x0, y0, x1, y1, x2, y2, x3, y3. By using that values, we can find f1, f2, f3. Use that f1, f2, f3 to calculate predicted value of y4. Use this predicted value to calculate the corrected value. If this predicted value and corrected value matches, then we stop. But if these two are not matching, then whatever corrected value of y4 we get, make use of that to find a new value of f4. Because what is f4? f4 is f of x4, y4. So y4 we use new corrected value and we find a new value for f4. And again we calculate y4c. If the two successive values of y4c matches, then we stop, and that will be the answer for the given term. Okay. So for predictor corrector, what are the things given? We are given dy by dx, so differential equation. We are given y at x not equal to y naught. 3 more points are given: y at x1, y at x2, y at x3. 3 more points are given. If it is not given, then we have to use the previous methods to get that 3 points: Euler's method or modified Euler's or Runge-Kutta method. But generally, for you, it is given in the exam. 3 points are given: x0, x1, x2, y1, y2, and y3. Making use of that, firstly, we have to find what is f1, f2, and f3. Then, using this formula, we predict value for y4, that we call as a predictor's formulas, Milne's predictor formula. Then this is a predicted value. So making use of next formula, okay, we try to correct this value. Okay, and for that, for finding, for that we use f2, f3, and f4. And for finding f4, f4 is nothing but f of x4, y4. And for finding, we use y4, which we got by using this predicted value. Okay, because y4 is not given in the problem. Y4 we want to find, y4 is the term which we want to find value of y at x4, that is asking the problem. So predictor value used to find a corrected value. If this predicted value and corrected value matches, problem gets solved. Whatever that get matched, that will be the final answer. But if these two value doesn't matches, then new value, what value of corrected value of y4 we get, use that corrected value, find f4 again. f4 previously calculated by predicted value. Now calculate f4 by using corrected value, and again do the calculation. We get new y4. If that new y4 and previous y4 If they matches, then that will be the answer. If it doesn't matches, then again use that new I4 and calculate new F4. Do the calculation again and simplify it, and making use of that, we have to continue until two successive values of y4 get match. So this is also an iterative method as that of modified Eulers. We have to use this formula, corrected formula repeatedly. Predicted formula we use once only, but corrected formula we have to use repeatedly until the values get match. Okay, so for predictor corrector, only two formulas we have to remember. One formula is for predictor, and other formula is a corrector formula. Okay, and carefully remember the meanings of F1, F2, F3, and F4. Okay, this is also very easy. Simple formulas are there. Just properly remember where is plus, minus, and which are the suffixes. Okay, we'll take the problem, then you understand how to make use of these formulas to solve the problem. Given dy by dx is equal to x square y square plus y square divided by 2, and y at 0 is 1, y at 0.1 is equal to 1.06, y at 0.2 equal to 1.12, y at 0.3 equal to 1.21. Evaluate 0.4, y at 0.4, correct up to 3 decimal places by predictor corrector method. Okay, so for predictor corrector we need these points: y0, y1, y2, y3, x0, x1, x2, x3, and that are given in the problem. F of xy, that is also given. So firstly take this as f, then find out f0. x0 is 0, y0 is 1. So f0 will be f of x0, y0. Put this x0, y0 into this function and then simplify it. Then these are x1, y1. x1 will be 0.1, y1 will be 1.06. Then find f1, that is f of x1, y1. x1 is 0.1, y1 is 1.06. So f1 will be f of x1, y1. Put this x1, y1 into this function, do the calculation, that gives us f1. Next term is x2, y2. x2 is 0.2, y2 is 1.12. Put this into the function, that gives us f2. So f2 will be f of x2, y2, that is 0.2 square into 1.12 square plus 1.12 square divided by 2. So that comes out to be 0.6523. Find out f3. For that we need x3, y3 is 0.3, y3 is 1.21. So f3 will be f of x3, y3, that is 0.3 square into 1.21 square plus 1.21 square divided by 2. That is 0.7979. Now use the predictors formula. For that we need f1, f2, f3, that already we have calculated. So using these three values, find out predict the value y4p. So by using the predictors formula, y4p is equal to y0 plus 4h by 3, 2 times f1 minus f2 plus 2 times f3. Substitute the values of f2, f1, f2, and f3, which we have calculated just now. We know what is y0, we know what is h, and then simplify them. Just simple calculations we have to do to get predicted value. Now take this predicted value as y4. X4 is nothing but x3 plus h. Difference between the two, any two values of x is 0.1. So x4 will be 0.3 plus 0.1, that will be 0.4. y4 we take it as a predictor value 1.2771, and we calculate f4 because we want to find a corrected value of y4. For that we need f4. So f4 will be x4 y4. Y4 we are taking predicted value. So it is 0.9460. Doing the calculation with these values, it gives us 0.9460. And now use the correctors formula. So by corrector formula, y4c will be y2 plus h by 3 into f4 plus 4f3 plus f4. Substitute the values, do the calculation. So the corrected value is 1.2797. Okay. Now, predicted value is 1.2771 and the corrected value is 1.2797. Okay. Now it is asked up to 3 decimal places. Now they are matching up to 2 decimal. Third decimal, here it is 7, here it is 9. So we have to do further calculation. How to do further calculation? Now take this corrected value of y4 as a new value for y4 and calculate f4 again. Previously what we have done, we calculated f4 by using the predicted value. Now calculate y4 by using this corrected value and use that new f4 to calculate new y4 corrected value for y4. So first find what is new f4 with this new y4. So this is these are the terms we know. X4 is 0.4, y4 is this corrected value 1.2797, and making use of this, find y4 first. Y4 will be f of x4 y4. So substitute these values into original function and simplify the terms. And whatever value of f4 we get, use that new f4 to get new y4. Okay. So simplifying the terms, substituting the values. As the simple calculations we have to do, f4 will be 0.9498. Put this value into corrected formula. So the new y4 will be same formula, y2 plus h by 3, f2 plus 4f3 plus f4. Now we are using this new f4 here. So simplifying it, y4c will be 1.2798. Previously it was 1.2797. Now we got 1.2798. So these two are matching up to 3 digits. So this we take it as a final answer. Since these two matches up to 3 decimal places, so the value of y4, that is y at 0.4, will be 1.2798. If the corrected and predicted value matches, then we stop. But if it doesn't matches, then find f4 with that corrected value and do the calculation. Then whatever f4 we get, with that new f4, find y4 again. If this previous value of y4 and this value of y4 matches, then we get the answer. But if these two doesn't match, then again we find f4 with new value and we find new y4, corrected value of y4. Then check that two matches or not. If the two matches, then that gives us the answer. Continue until two corrected values of y4 matches up to certain decimal places. That gives us the answer. Okay. So only for corrected value we use the iteration. If predicted and corrected value doesn't match, then only we have to repeat these steps. Consider the last problem. Given dy by dx is equal to x minus y square and y at 0 equal to 0, y at 0.2 equal to 0.02, y at 0.4 equal to 0.0795, y at 0.6 equal to 1 0.1762. Evaluate y at 0.8, correct up to 3 decimal places by predictor-corrector method. So again, you write down the given term as f of xy, dy by dx equal to x minus y square equal to f of xy. Then first term is x naught, y naught. Y at 0 is 0 means x naught is 0, y naught is 0. Then find f0 making use of that. X naught is 0, y naught is 0, so f0 will be f of x0, y0. So that will be 0 minus 0 square. That is 0. The next term is f of 0.2 equal to 0.02. So x1 will be 0.2, x2 will be 0.02, and make use of that x1, y1 to find f1. So f1 will be f of x1, y1, that is 0.2 minus 0.02 square. It is equal to 0.1996. Take the next point, y at 0.4 is 0.0795. So that is x2, y2. So x2 is 0.4, y2 is 0.0795. Get f2 from it. Simple calculation. Putting these value into the function, we get f2. That is 0.3937. Use the next point, that gives us f3. x3 is 0.6, y3 is 0.1762. So f3 will be 0.6 minus 0.1762 square. That will be 0.5689. Now, use these three values of f to calculate the predicted value for y4. So the formula, by using formula, predicted value of y4 is y0 plus 4h by 3, 2f1 minus f2 plus 2f3. So substitute y0, f1, f2, f3 and h in the formula and do the calculation. So the predicted value of y4 will be 0.3049. Now take this as y4, take x4 as x0, x0 plus 4h or x3 plus h. x3 is 0.6, h2, difference between any two values of x is 0.2. So x4 will be 0.8 and taking this as y4. And f4 will be f of x4, y4. That will be 0.707. And now calculate by using corrected formula value of y4. It will be y2 plus h by 3, f2 plus 4f3 plus f4. Substitute all these values into the function. If this value and predictor value match, then we'll get the answer. Doesn't match, then repeat the steps with new y4. Do the calculation. Simple calculations are there. So corrected value comes up to be 0.3046. What is the predicted value? 0.3049. And you can see that these two matches up to 3 decimal places. That is what our requirement. So this is the answer. If these two doesn't matches, then we take this as a y4. We calculate new f4 and new y4 again.